Hello everybody, welcome to Worst Case Depressurization Test. This is a self-study module that's intended for you to have a step-by-step review of how we at CETA do a worst case depressurization test. This is according to the IWAP standards, so if you want any more detail and you want to find out a little bit more about how this is done, please pick up that standards book, go to that section, and find out exactly what we're talking about here. So this self-study module, like all self-study modules, is intended for you to go at your own pace. So if you want to rewind it and watch the whole thing over, if you want to pause it, maybe watch a certain part over and over again, that's completely fine. It's also completely fine for you to look at the standards, Google, anything that you want. But after you're done, you will be expected to complete the activity that you've been given. You'll need to print that activity out, fill that activity in, and bring it to the classroom so you can get full credit for this class. So let's go ahead and get started. What we're going to learn from this class, or from this self-study module, is simply a review of what the exact steps are to run worst case depressurization. So in this test, which is part of our full combustion suite, but not the whole combustion suite, we take it from the beginning. And in the beginning, we set up the house to be in winter conditions. That's all the outside doors closed, all the outside windows closed, and all the inside doors open. We've also already set up our manometer so that we are referencing the CAS pressure to the outside pressure. So once we've done that, the first step in determining worst case depressurization is just turning on all the exhaust in the house. That includes the dryer. Once you've got all the exhaust turned on, you can take a look at your manometer. You've got a CAS pressure there, and you want to record that. You want to make sure that you document that. All right? So if you've already exceeded your worst case depressurization limit, then you want to make sure that you know that you need to do something about the exhaust fans. Step 2 in determining worst case depressurization is turning on the air handler. All you have to do, turn that air handler on, whatever it takes to get it on, turn it on, and then record the CAS pressure. Now, if you've exceeded the worst case depressurization limit at this time, then it's probably a good chance that there's something going on with the ductwork or the air handler itself. You're going to want to take a close look at what's going on around that furnace. Okay? The third step in determining worst case depressurization is testing room pressure. So while the air handler is on, you're going to go from room to room with the smoke stick, and you're going to open up the rooms that are negatively pressurized, which means they'll suck the smoke in, and then you're going to close the doors to the rooms that are either positively pressurized, they're blowing the smoke back, or they're just neutral. They don't do anything to the smoke. That way we're going to start to really get a good idea of what our worst case depressurization configuration is. Well, once you've done that with the doors, now you want to record that CAS pressure. Make sure that you're using the same document and it's an up-to-date document. So now that we've gone through all those steps, we're ready to take a look at our list, at our document that we're using. And the worst case depressurization that we have on that list, or the worst case configuration, is going to show us, is going to be the largest negative value. So once we find that largest negative value, then we know what the worst case configuration for that house is. Then we're going to record that at the bottom of the list. So now that we have our worst case depressurization and the configuration, now what we need to do before we can move on to spillage testing, and after that carbon monoxide testing, the next thing we want to do is make sure that we reference our worst case depressurization limits table. This table is also found in the standards. It's very simple. You're going to want to choose what kind of furnace or appliance you're testing, and you're just going to want to reference that versus the height of that appliance and whether or not that appliance is lined, unlined, or on an exterior wall or not. By doing that, you can find out what your worst case depressurization is for that house, and since you already know your configuration, you can figure out if you have exceeded that limit. If you have exceeded that limit, you need to make a call and fix it. Call for something to fix it. So go back to your worst case depressurization steps and figure out from there where it went wrong. Thanks a lot. We'll see you.